Hello, welcome to 13 Universal. This is biology session with Shedro. So this is A-level biology and we're going to be solving questions on biology topics, especially enzymes. So this is Enzymes Series 2. So if you have not watched Series 1, make sure you watch it and follow us up. Series 1, a lot of explanation, but we'll continue in Series 2. So the first question here says, and the enzyme lysozyme secreted from the tear glands. So read the question with me. Tear glands form deposits on contact lenses. Which ingredients would be effective in a contact lens cleaner for removing these deposits? Which ingredient will be effective? Is it ethanol, lysosomes, and pH buffers, processes? So which one do you think is the answer? Okay, now enzyme lysozyme is an enzyme, is a protein. So what can we use to digest protein? Ethanol cannot digest protein. It cannot even dissolve it because most proteins are polar. Alright, so we need something that can use to clean it. Lysosomes contain digestive enzymes, but not all of them. Not all digestive enzymes in lysosome digest protein. Okay, pH buffers maintain constant pH. They do not digest proteins. Okay, the best is proteases. Proteases digest protein because enzymes are protein. So enzyme lysozyme can be cleaned, removed using proteases. Okay, so the answer is what? Proteases. Let's go to the next question. So which is correct for competitive inhibitors? Which is correct for competitive inhibitors of enzymes? Alright, the first one says occupies the active site. Second says they have exactly the shape of as a substrate. They can be used to control the rate of reaction, enzyme rate of enzyme activity. 4, they can bind to a site on an enzyme other than the active site. So which one do you think is the answer? What do you think is the answer? So remember we said last time. Now the question is, what is a competitive inhibitor? Alright, competitive inhibitor is an inhibitor that binds to the active site of an enzyme because it has a complementary shape. So this is an enzyme. This is a substrate. Let's assume this is a substrate. And maybe this is the inhibitor. So inhibitor, the shape somehow, this is inhibitor. Okay, that is the enzyme. Right, this is substrate S. So see, the substrate and its inhibitor, they are similar. Okay, they are not exactly the same, and the shape of substrate of the inhibitor is complementary to the active site. So when it binds to the active site, it blocks the substrate. Right, the question is that they occupy the active site of an enzyme. Yes, they can bind to the active site because they have complementary shape to the to the active site. Okay, this can fit in this, right? They say they have exactly the same shape as the substrate. No, they have similar shape. So this is wrong. Number 1 is correct. 3 says they can be used to control the rate of reaction, enzyme activity. Sorry, yeah, all inhibitors can control rate of enzyme activity. They can slow it down. So because when it binds to the active site, it blocks the substrate and thereby slowing down the reaction or stopping it. So 3 is correct. 4 says they can bind to a site on an enzyme other than the active site? No, they bind only to the active site. Okay, they are not non-competitive. So the answer here is 1 and 4. Okay, no, 1 and 3. Okay, because 2 is wrong, 4 is wrong for a competitive inhibitor. So 1 and 3 is B. So B is the answer. Okay, all right, let's go to the next question. The graph shows the course of an enzyme catalyzed reaction at 30. Okay, look at it. So what is true at X? All right, look at X here, guys. This X, if you trace it up, this is where we have initial rate of reaction. Okay, the graph is still very steep. Okay, so rate of reaction is I think it's fastest here because this is very steep. All right. Okay, so what is happening here, guys? Most enzymes molecules will have free active site. Not exactly, because we still have a lot of substrates at the beginning. Okay, we're mixing fixed amount of substrate and fixed amount of enzyme together. So there are a lot of substrate molecules present here. So they will occupy most of the enzyme's active sites at the beginning here. Okay, so A is not the answer. B says the number of available substrate molecules is high. Yes. And let me say this, that one of the factors that affect the rate of reaction here is the amount of substrate molecules present. They are the ones that determine, okay, rate of reaction here. If you have more substrate, reaction will be faster or steeper. Okay. So, okay, let's look at C. The number of enzyme substrate complex is low. Not exactly correct, because we have a lot of substrate molecules and we have enzymes active sites available. So enzyme substrate complex may not be low. Okay, then the rate remains the same if more enzymes added. No, it's talking about somewhere here. The rate, of course, will not remain the same. It says the rate remains the same if you add more enzymes, the rate will not remain the same as well. Okay, because you're increasing enzyme concentration, it will increase rate of reaction. All right, B is most likely answer here. Okay, so let's go to question 4. The statements about enzymes, they are globular. Do you accept that? Globular, they are coiled into ball-like shape. Okay, and then the hydrophilic R groups are found on the surface. Globular. Okay, they are found in smooth endoplasmic reticulum. Smooth endoplasmic reticulum does it make enzymes? Okay, they are found only attached to the plasma membrane. They can be inhibited by competitive inhibitors. Which segments are correct for all enzymes? Pause the video and try. So guys, don't forget that enzymes are globular proteins. Okay, so the question is, what are globular proteins? Globular proteins are proteins that are called up. They are called up into a ball-like shape, ball-like or spherical shape. This is spherical or ball-like, so that hydrophilic R groups are on the surface. Hydrophilic R groups are on the surface. Hydrophobic are within the core. So can you see that? Yeah. So hydrophilic R groups interact with water. So all enzymes are soluble because they are globular. Okay, and they're metabolically active. So number 1 is correct. All right, number 2, they are found in the smooth endoplasmic reticulum. No, smooth endoplasmic reticulum does not synthesize protein. Remember, enzymes are proteins. It synthesizes lipids and steroids and also transport lipids and steroids. So 2 is not correct. 3 says they are only found attached to plasma membranes in the cell. No, they are not only found attached to plasma membranes. Some of the most enzymes are in the cytoplasm or in some organelles. So this is not true for all enzymes. Okay, all enzymes. It's true for some enzymes, but not all enzymes. Okay, but all enzymes are globular. This is 2 is not true. 3 says they can be inhibited by competitive inhibitors. Yes, all enzymes can be inhibited by competitive inhibitors. Okay. Yeah. So the answer is 1 and 4. Okay. A is correct. So number 5 says an unusual enzyme has been found in tropical grass. It says it catalyzes the hydrolysis of fungal polysaccharide chitin into amino acid. It also inhibits the activities of an enzyme in locust guts, which catalyzes digestion of amylose. What describes the actions of this unusual enzyme? Okay, now you can pause the video and try to solve it. But you see, they say it catalyzes hydrolysis. So hydrolysis is a breakdown of fungal polysaccharide. So let's come to the option hydrolysis. So don't forget that polysaccharides contain monosaccharides joined by glycosidic bonds. So hydrolysis of polysaccharides is breaking of glycosidic bond, not peptide. Peptide bonds are not found in polysaccharides. They are not found in polysaccharides. It's only glycosidic bonds that are found there. So that eliminates C and D. Alright? So our answer is likely A and B. Let's come to reactions inhibited. Look at what I said the second one. It also inhibits activity of an enzyme in locus which catalyzes digestion of amylose. Amylose is a polysaccharide. Digestion of amylose is hydrolysis, okay, of glycosidic bond, not condensation. So it catalyzes hydrolysis, inhibits hydrolysis. So the answer is B. Okay. So the answer is B. What do you think? Send us your thoughts. Alright, want to know what you're thinking. Okay, this drug ritonavir is sometimes used in the treatment of HIV/AIDS. Ritonavir consists of 3 amino acids and is a competitive inhibitor of HIV protease. HIV causes this protease enzyme to be made inside human cells. So it's made inside human cells. Ritonavir produces many side effects as it interferes with many metabolic processes in humans. Which statement about ritonavir are correct? Okay, ritonavir has a shape complementary to active site. Ritonavir will enter human cells directly through the lipid bilayer and not require any transport proteins. Is that correct? Ritonavir is likely to inhibit many of the enzymes of human cells. Complete hydrolysis of ritonavir would require the addition of 3 water molecules. Okay. Okay. So what do you think is the answer? So let's look at it again. It says it is used in the treatment of HIV. It consists of 3 amino acids and is competitive inhibitor. So they mentioned some clues, important clues. It is competitive inhibitor. Okay. HIV causes this protease to be made inside humans, so it goes inside human cells, passes through cell surface membrane, and produces many side effects. That means it interferes with many reactions. Okay, see many side effects as it interferes with many metabolic processes. Okay, so it's not specific. It's very important. All right, let's work on this. Now the question says, okay, look at let's check whether this is correct. Ritonavir has a shape complementary to the active site. Yes, it's a competitive inhibitor. So 1 is correct. Okay. 1 is correct. Okay. 2 says ritonavir will enter human cells directly through lipid bilayer and not require any transport protein. Now, it is made up of 3 amino acids. Amino acids are polar, so polar molecules do not pass through lipid bilayer. Lipid bilayer will repel it. So this is wrong, because lipid bilayer will always repel polar molecules. They have to pass through transport proteins. So 3 says ritonavir is likely to inhibit many of the enzymes of human cells. Yes, because they said that it has many side effects. So it's inhibiting many, not just one. So that number 3 seems to be correct. Okay. Yeah. So quickly, number 4 says complete hydrolysis of ritonavir will require the addition of 3 water molecules. All right, guys, we need to look at something here. Watch this. Okay, it's made up of 3 amino acids. Let's assume this is the first amino acid. All right, join to the second. This is the second amino acid. Join to the third amino acid. Okay. All right. Anytime you break one amino, you break this peptide bond, you produce one water molecule. Break the second one, produce second water molecules. So mathematically speaking, so water, number of water molecules produced, okay, during hydrolysis of chain of amino acid, okay, if you follow it, is equal to n minus 1. So n is number of amino acids. I mean the number amino acids here is 3. Okay. So that will be 3 minus 1, which is 2. So is that okay? So if you do complete hydrolysis, you will not get 3 water molecules, you get 2. So that makes 4 wrong. The answer is 1 and 2. 1 and 2. Okay? Yep. 1 and 2. Which of the statements describes some roles of enzymes? Catalyzes the breakdown of larger molecules into smaller ones. Lower the activation of energy required to start a reaction. Increase the number of collisions between molecules. Supplied activation energy required to start a reaction. Right. A, B, C, D. Which one do you think is the answer? Let's walk through it. So which of the statement describes some roles of enzyme? Okay, catalyze the breakdown of larger molecules into smaller. Yes, enzymes can do this. They can break down large molecules during hydrolysis reaction. Number 2 says lowers the activation energy required to start a reaction. Yes, they lower activation energy. That's their function. They lower activation energy. This is how they increase rate of reaction, by lowering activation energy. 3 says increase number of collisions between. Enzymes don't do that. What increasing number of collisions is either temperature or increasing substrate concentration or enzyme concentration. Okay, not enzymes. 4 says supplies activation energy. No, they don't supply, they just lower. So it's only 1 and 2. That's correct here. 1 and 2. Okay. The 8 says the graph shows. Okay, I think this question is not complete. Okay. It says okay. Now it says the graph, okay, shows the rate of activity of enzyme sucrose plotted against concentration of sucrose. So this is concentration, independent variable. This is rate dependent. Is why does the rate of enzyme activity remains constant? So from 8, this is 80. Why does it remain constant here? All right. So, but we don't have the options. It's a typo error. Let's go to number 9. All right. Which graph represents the action of non-competitive inhibitor? Okay. Now, non-competitive inhibitor lowers rate of reaction. So this looks like it. B, nope, it doesn't go up and come down. There's not this, it's neither this. It doesn't reach the same Vmax as without, because it's a without inhibitor. So non-competitive cannot give us the same maximum rate of reaction without inhibitor. So C and D is out of it, and the reaction does not go up, rate does not go up and then comes down. So A is the answer. See, it lowers the rate of reaction. Okay, so that is why. Right, A is the answer. This is typo error. A is the answer. Okay, A is the answer. Now I say, why do large increases in the large increases in the temperature or pH alter the enzyme activity? Okay, look at the point here. Pause the video and try to solve it. Why do large increases in the temperature or pH alter enzyme activity? Number one, they change the three-dimensional shape. So anytime there's increased temperature breaks hydrogen bonds, and of course both increase in temperature and pH break hydrogen bonds. Hydrogen bonds help to hold the tertiary structure of an enzyme, which is the active site. pH breaks ionic bonds, which also part of maintaining the active site. So if this will break, and then the three-dimensional shape is the active site, so it will be lost. So the change, yeah, this is correct. It said they disrupt hydrogen and ionic bonds, and that's how they do it. They break these bonds. They increase hydrophobic interaction in the enzyme. They do not increase hydrophobic interaction. All right. So they do 1 and 2. 1 and 2. The answer is A. So guys, thank you for watching. Thank you so much. So wanted to like our videos, share, subscribe, and make a comment. All right. See you next series 6-3. Bye.